Welcome to this explainer. Right now, there's a massive shift happening literally right beneath our feet. Modern AI workloads generate so much heat and draw so much power that traditional data centers are quite literally melting under the pressure. If you're still relying on the old ways to run your new tech, you're already behind. Today, we're exploring why the unprecedented density of modern AI is forcing a total rethink of data center management. So here's our roadmap for today. We're going to hit the data center dilemma, the three connected domains, Supermicro's converged solution, real-time telemetry and action, and wrap it up with the future of orchestration. Let's get into it. All right, part one, the data center dilemma, moving beyond legacy DCIM. Traditionally, if you're running a data center, you've been forced to juggle entirely separate apps for your daily ops. You've got one tool for your servers, a totally different platform for your power distribution units, and yet another disconnected interface just for cooling. It's a deeply fragmented, siloed web. Sure, your facilities team can see individual components, but they're completely missing that single, unified view of how compute demand, rack power, and facility cooling actually impact each other. It's kind of like trying to tune a high-performance engine while blindfolded, right? Your tools are essentially speaking different languages and hiding out of the picture. And because of these silos, you get these severe blind spots. Picture this. You're trying to deploy some critical new AI hardware, but you're constantly hitting workflow delays and dealing with manual handoffs simply because your tools just won't talk to each other. It kills your operational efficiency. And worse, it massively spikes the risk of configuration errors, which, as we know, lead to incredibly costly outages. Throw in the integration complexity across multiple vendors and protocol headaches with Redfish, SNMP, and Modbus. It's a complete nightmare that leaves teams scrambling to manually bridge the gaps while the clock is ticking. To really bridge that gap, we've got to look at how conventional business compute stacks up against our new reality. Back in the day, managers only had to monitor compute, networks, and storage. And hey, that used to be enough. But today, intelligent power and cooling infrastructure are absolutely mandatory for high-density AI and modern enterprise workloads. Without them, the whole system just falls apart. You simply can't run tomorrow's high-octane technology on yesterday's management assumptions. It just doesn't work. Moving on to part two, the three connected domains, a new architectural necessity. We've officially hit a new architectural necessity, the converged infrastructure ecosystem. Systems, power, and cooling are deeply, inextricably linked. The big takeaway here is that none of these areas can operate in a vacuum anymore. They form this interconnected, living ecosystem, where a tweak in one instantly ripples through the others. Let's break these down to really see why this changes everything about how we design and run data centers. First up, the systems domain, which has radically evolved. We're talking about the dense compute and network gear right inside the rack, your CPUs, GPUs, storage, switches, the whole shebang. It's pretty wild to think that modern racks aren't just simple server collections anymore. They are literally supercomputers packed into a single zone with dependencies that are mind-bogglingly more complex than setups from just a decade ago. Next is the power domain. This covers how energy is delivered, measured, and protected. And here's why this is a real game changer right now. Higher density systems are incredibly thirsty. They draw massive amounts of power. So rack-level power awareness isn't just a nice-to-have anymore. It's absolutely critical. You need it for capacity planning, maxing out efficiency, and most importantly, preventing some highly dangerous overloads as these dense systems pull extreme current. And finally, the cooling domain. This is your thermal infrastructure. Everything from liquid cooling to leak detection, all the way out to facility cooling towers. As these racks get denser and much hotter, cooling is no longer just a building services issue that you toss over the fence to the facilities team. It's directly tied to whether your ridiculously expensive AI GPUs can actually perform. If your systems hit a thermal ceiling and throttle, you are actively burning through millions of dollars in compute investments. It's seriously that urgent. So, imagine being the facility manager staring down the barrel of these interconnected dependencies. How do you actually manage a system where compute, power, and cooling all critically rely on each other? If you're out there on the data center floor facing this insane density, you already know the old fragmented tools just aren't going to cut it anymore. A totally new approach is required. Which brings us to Section 3, Supermicro's converged solution, unifying the ecosystem. Enter SuperCloud Composer, or SCC. This is an open, distributed infrastructure management platform built on a highly scalable Kubernetes control plane. What it does is unify systems, rack power, and cooling into one single streamlined dashboard. Basically, it's the foundation that lets you discover, monitor, and manage this entire converged ecosystem through a single pane of glass. One unified screen where everything is visible, correlated, and most importantly, actionable all at once. Let's actually see this continuous, intelligent loop in action. Step 1, sensors are constantly on the lookout, detecting heat, airflow, or power risks using smart environmental monitoring. Step 2, the software instantly cross-references your SLA commitments, capacity limits, and even real-time energy grid prices. Step 3, it dynamically automates the GPU workload. It'll shift, schedule, or throttle workloads to perfectly match those specific facility constraints. It's this brilliant, continuous cycle that protects your hardware while keeping uptime at an absolute maximum. All right, Section 4, real-time telemetry in action. From blind spots to actionable intelligence. When you map physical problems directly to automated software workflows, the power of this converged setup becomes totally obvious. Let's say a PDU overload risk pops up. The system instantly alerts operations and fires off critical events via webhooks. Or say there's a cooling temperature breach, it automatically triggers a critical thermal escalation, way before your hardware has a chance to melt down. And if there's a physical leak, a critical alarm sounds and initiates immediate workload protection actions. By fusing power and cooling telemetry, operators can actually stop catastrophic outages dead in their tracks in real time. And honestly, the depth of visibility you get with SEC modules is just staggering. You're not just glancing at the rack, you're getting outlet-level power consumption and phase imbalance alerts. You're tracking real-time PUE and energy prices to actively drive down your operational costs. You're monitoring the coolant flow and pump status right from the liquid cooling device deep inside the server, all the way out to checking the water quality and basin levels of the massive cooling towers outside. It's complete end-to-end operational awareness, literally connecting the micro to the macro. Now for our final part, Section 5, the future of orchestration. Smart, self-healing data centers. The ultimate goal we're speeding toward is policy-driven orchestration across all your resources. We are rapidly moving toward a world where your data center seamlessly balances its hyperdense infrastructure across a bunch of complex energy sources. Think about orchestration that automatically shifts loads between the traditional grid, battery energy storage systems, solar microgrids, and eventually emerging stuff like nuclear and small modular reactors. The data center actually becomes a truly active participant in the energy grid. How cool is that? This next stage is a massive leap forward. We're talking full energy source orchestration and intelligent, cooling-aware compute throttling, meaning it automatically dials back CPU and GPU power the exact second cooling capacity drops, physically preventing a catastrophic thermal failure. But honestly, the most exciting part is predictive maintenance. By leveraging real-time telemetry across all three domains, the data center can spot tiny degradations and fix them before they ever impact your AI workloads. The data center literally transforms into a smart, self-healing environment. So I'll leave you with this final thought to chew on regarding the future of your own operations. Is your management software truly ready for the immense density, thermal demands, and converged infrastructure of tomorrow's AI? Because the era of fragmented tools is officially over. Survival now absolutely relies on unified intelligence. Thanks so much for joining me on this explainer. Until next time, stay curious and stay focused on the future.